We are one step closer to answering the age-old question: are we alone in the universe? The James Webb Telescope has provided an astonishing discovery that may hold the answer. It has captured images that resemble glowing alien cities on the dark surface of Proxima Centauri b, a planet just over 4 light-years away. This unexpected finding has left scientists stunned and sparked intense debates. Could these lights be evidence of intelligent life-building structures and thriving in the darkness? Or is there a completely different explanation for these strange emissions? Let us uncover the truth behind these eerie images that have reportedly caused the elimination of all scientists involved in the project. The James Webb Space Telescope, JWST, a marvel of modern engineering, has captured an astonishing image of city lights flickering from billions of miles away. This discovery has ignited imaginations about the possibility of life beyond our solar system and has furthered our understanding of the vastness and complexity of the universe. The image, taken by JWST's near-infrared camera, NARCam, shows a cluster of galaxies known as the Sparkling Jewel, located approximately 5 billion light-years away. Within this cluster, astronomers have identified a distinct pattern of light that resembles the familiar glow of city lights on Earth. This unexpected observation has sent shockwaves through the scientific community, raising questions about the nature of these light sources. While the initial interpretation suggests the possibility of extraterrestrial civilizations, scientists are cautious about drawing hasty conclusions. Several potential explanations for the observed light patterns are being explored. The James Webb Space Telescope is a revolutionary instrument that has ushered in a new era of astronomical observation. Its advanced technology, including a large primary mirror and infrared imaging capabilities, allows us to see deeper into space than ever before. This enables us to study the earliest galaxies, the formation of stars and planets, and the composition of exoplanet atmospheres. JWST's unprecedented capabilities have already yielded a wealth of groundbreaking discoveries, including the detection of water vapor in the atmosphere of an exoplanet and the observation of distant galaxies that formed shortly after the Big Bang. The discovery of city lights in the Sparkling Jewel cluster adds to this growing list of scientific breakthroughs. Proxima Centauri b orbits the closest star to our solar system, Proxima Centauri, and is approximately 1.3 times the mass of Earth. Positioned in the habitable zone of its star, it theoretically has conditions that could allow liquid water to exist. However, its proximity to the star also poses significant challenges, as the intense radiation and solar flares create a hostile environment for life. Despite this, the peculiar lights suggest that something, or someone, has adapted to survive. As we delve deeper, these lights may turn out to be more than just a scientific anomaly, and what we uncover next might challenge everything we know. The James Webb Telescope's advanced infrared capabilities allowed it to gather unprecedented data from Proxima Centauri b. Scientists observed heat signatures and light emissions that defied natural explanations. Typically, rocky planets absorb sunlight and emit infrared radiation in predictable patterns, but Proxima Centauri b's emissions were anything but ordinary. The lights resembled the patterns of city illumination observed on Earth from orbit, raising the question of whether these signals are artificial, created by intelligent life, or caused by an unknown natural phenomenon. Researchers have been examining the planet's atmosphere and surface composition to unravel the truth. The telescope's sophisticated instruments can detect elements like oxygen, methane, and water vapor, indicators of potential habitability. Early findings suggest that the planet may have an atmosphere capable of supporting life, despite the radiation challenges from its star. This opens up exciting possibilities. Could an intelligent civilization have developed advanced technologies to shield itself from the harsh environment? For instance, Massive solar collectors on the planet's day side might harness energy to illuminate and warm the perpetually dark night side. While the initial interpretation suggests the possibility of extraterrestrial civilizations, scientists are cautious about drawing hasty conclusions. Several potential explanations for the observed light patterns are being explored. Active galactic nuclei, AGN. These are supermassive black holes at the centers of galaxies that emit intense radiation. The light patterns could be caused by active galactic nucleus activity in nearby galaxies within the cluster. Starburst galaxies. These galaxies are undergoing rapid star formation, producing a high concentration of young, hot stars that emit copious amounts of light. The observed light could be emanating from such star-forming regions. Gravitational lensing. The massive gravity of the galaxy cluster can bend and distort light from objects behind it, creating multiple images of the same object. The observed light patterns could be a result of gravitational lensing effects. Further research and analysis are necessary to determine the true nature of the light sources. However, the possibility of extraterrestrial civilizations remains an intriguing prospect that is fueling ongoing scientific exploration. The concept of tidal locking adds another layer of complexity. Proxima Centauri b likely has one side that constantly faces its star, while the other remains in perpetual darkness, creating extreme temperature differences. Without an atmosphere to redistribute heat, one side would scorch, while the other freezes. Yet the presence of city-like lights suggests some form of thermal management. Could this be evidence of advanced technology maintaining habitable conditions on an otherwise inhospitable world? Astronomers have long been fascinated by the search for extraterrestrial life, and Proxima Centauri b represents one of the most promising targets. The telescope's detection of lights has reignited discussions about the existence of alien civilizations. David Kipping, a researcher at Columbia University, noted that these emissions challenge everything we know about rocky planets. If the lights are artificial, they could signify a society far more advanced than our own. If natural, their origins could reshape our understanding of planetary science. The implications of this discovery extend far beyond Proxima Centauri b. The telescope's ability to detect faint signals opens the door for future exoplanet exploration. By studying light patterns and heat emissions, scientists can identify planets that might harbor life. Its sensitivity to infrared radiation enables it to peer into the atmospheres of distant worlds and reveal their chemical compositions, a critical step in determining whether a planet is habitable or already inhabited. While the telescope has provided groundbreaking insights, it does have limitations. For example, it struggles to detect bound oxygen, a key indicator of life in exoplanet atmospheres. However, future instruments like the Extremely Large Telescope, ELT, scheduled to begin operations in 2028, promise to bridge this gap with larger mirrors and advanced spectroscopic tools. Until then, the James Webb Telescope remains our best tool for uncovering cosmic mysteries. The discovery of city-like lights on Proxima Centauri b raises profound questions about the nature of life in the universe. If intelligent beings do exist on this planet, their survival strategies might differ vastly from anything we can imagine. Perhaps they have evolved to withstand intense radiation or develop technologies far beyond human ingenuity. Conversely, if the lights have a natural origin, they could reveal processes previously unknown to science. One emerging theory is that the lights are created by extremophiles, microorganisms capable of surviving extreme conditions. Such hardy life forms thrive in environments previously thought uninhabitable, like Earth's deep-sea hydrothermal vents. If similar organisms exist on Proxima Centauri b, they could produce bioluminescent light as a byproduct of metabolism, explaining the emissions without requiring advanced technology. Another possibility is geological activity. Volcanic eruptions could release gases that glow under specific conditions, or minerals on the surface might reflect and amplify starlight, mimicking artificial illumination. While these explanations are less dramatic than alien cities, they are no less important for understanding the planet's unique properties. The strange lights on Proxima Centauri b continue to raise more questions than answers. Scientists are cautious, emphasizing that extraordinary claims require extraordinary evidence. Further observations will be crucial to confirming the light's origins. In the meantime, this discovery has reinvigorated interest in the search for extraterrestrial life. As humanity explores the cosmos, each new discovery brings us closer to answering whether we are truly alone. Whether these lights represent alien civilizations, bioluminescent microorganisms, or a natural phenomenon, they highlight the vast possibilities awaiting us in the universe. The Proxima Centauri b findings remind us of the endless mysteries of the cosmos and our boundless curiosity to uncover